And welcome back to the Masterclass Data AI, ML, and RPA stage. And with me, I've got Zhamak Dehghani from ThoughtWorks. She's the Director of Technology for ThoughtWorks North America. Thank you for being with us.
Thank you for inviting me. It's great to be here. It's 6:37 a.m. my time.
I couldn't apologize enough for that. We're so sorry for it being this early, but we're so grateful to have you with us.
It'll be great to be here.
Yeah.
All right. Cool. Shall I share my screen? Or?
Sure thing. You can take it from here. I'm going to be with you throughout the presentation, hidden away here, and I'm going to take the questions at the end. So everyone watching us, please don't hesitate to post any questions or anything you want in the chat. We're going to discuss it at the end. And good luck.
Thank you.
See you on the other side.
Sure. We'll be back soon. All right. Let's talk about data mesh. Are you focusing my screen?
Yeah, no worries.
All right. Great. Why data mesh, what it is and how. We have an hour and a half together. So I'm hoping to kind of give you a very kind of holistic perspective of what this thing that we call data mesh is. As mentioned, I am I'm the founder of this concept, data mesh. I work with ThoughtWorks, and I'm the Director of Emerging Technologies in North America. If you have really good eyesight, I have put 2 URLs for you, which takes you to the free pre-release access for 2 of the books. One I'm finishing up this year, and one is going to be published in a next few days. You can purchase it, but these 2 links will give you free access to O'Reilly platform, which then gives you free access to the early unedited version of these books. Oh, sorry. My thing is jumping around. Okay. So I want to talk to you about what I consider kind of the next generation or the future of data architecture and an organization as well, data organization, how we organize ourselves. But to talk about present, to talk about future, we need to understand the past. This talk is going to be fairly high level. So I would like you to, for the rest of this talk, suspend some of the biases, some of the assumptions that you have, and come on this ride. First, we'll go down the history lane for a little bit to look at some of the macro trends that have been happening in our industry for the last 20 years and accelerating. They're not definitely slowing down. And one of the things that is really important for us to pay attention to is this growth of organizational complexity that is coming with digitization. Organizations are spending more and more money to become digital. What does that mean? That means they want to use technology not only to enable the services, the products that they build, but also reshape and re-enable the business, like actually expand and reshape what they do with kind of digital offerings. These are a couple of stats. The first one shows the spending globally going from 500 billion to over 1,000 billion on just what is called digital transformations, like companies that have this agenda to change the way they work with, using computers and enable them with technology. And the other one is a little bit older. It's from 2019, where the 128 kind of global organizations were surveyed, and 70% of them, they had a strategic initiative at the CEO level to do some form of a digital transformation. And I'm pretty sure by the time that 2020 hits with pandemic, the rest of the 30% probably had some sort of a digital transformation on their corporate agenda with the challenges we had. So what does this mean? Why should we care about as technologists? What this means is that organizations are getting, they're accelerating the pace of change, they're accelerating the amount of data they're generating. They're becoming kind of more complex in terms of possible interactions, possible touch points they can have with their clients, right? Going from a slower manual kind of approach to business to a faster kind of wider approach with technology. So, in about the beginning of the 2006, 2007, and then to really the start of 2011, 2012, what I personally experienced was to respond to this organizational complexity that was coming with, running applications and a lot of our business with different applications, we saw this move of architecturally, we started changing the way we were building applications from monoliths to kind of decentralized distributed applications, right? I'm sure there are a few architectural styles in the middle, going from kind of monolithic to layered architectures to spoke and, hub and spoke applications with ESBs and so on. But finally, we landed on an architecture with containerization, with microservices, where the technology was being decoupled based on the business services that we need to build based on this autonomous kind of application. So if you were an e-commerce business, then you will have, a service for order management, a service for shipping, a service for, credit card processing, a service for user management. So we kind of, to address that organizational complexity that was coming with digitalization, we had to change the way we were building application. And organizationally, we also made changes. We had this functionally divided organizations where you had the business on one side and then central IT to another side, and have this. I'm even ashamed to say what I'm about to say, but have the people, the technologies as shared resources that we would just throw to different projects, and then once the application is built, we would throw it over the wall to the operations team to operate it. So we learned that this model wasn't conducive to rapid change. When you needed to build rapid features and rapid applications, every one of these walls was a point of friction. Not having the long-term ownership of what people are building was challenging because you lost the context of the developer that contributed to the application, and the next person comes in and the quality degrades over time. So then what we started doing was and what modern digital businesses do today, a lot of I'm in the Silicon Valley, a lot of the companies we look up to in terms of, the digital scale-ups and how they organize themselves, we started building these DevOps teams that, you have your product managers, people from the business working closely with the technical product managers, working closely with the devs that have the long-term ownership of what they build, and the devs run what they build, so they have the accountability for kind of operations of the applications. And they were organized around business domains, right? They were organized like you have people, if you're a giant retailer, and I've worked with one here in downtown San Francisco, the Gap Inc., that's how you organize yourself. You have people that are taking care of your sales, retail shops. You have people that take care of point of sales in the retail. You have people that take care of the routing and optimization of logistics. People take care of planning, and those folks are long-term owners of the technology, and they work very closely with the business, work very closely with operation. And finally, the other change, that macro change that has happened that we should pay attention to, that the relationship with data has inversed. So what do I mean by that? For the longest time, this is the relationship we've had with data. We run function, we run applications. Applications generate data as a byproduct of running the business. We keep that data as the state of that application, and we keep it on disk or files or graph databases or whatever form of database. So applications are generating data, and that data keeps the state of that application to serve the business, to run the business. But with the progress of using ML, all kinds of machine learning models in our features, in our applications, whether it's optimization of personalization, or whether we're optimizing pricing, or whether we're optimizing the design of the clothing, let's say for the next season, these type of ML-driven, kind of ML-based applications, it's the data that generates the function. It's the data, the patterns within the data that we exploit to actually generate the code that then, runs the business. So that relationship has inversed. So there's a lot of change that has been happening. But something that hasn't changed is our approach to managing, sharing, accessing data for analytical use cases, for ML training, for insights, for reports. And I know at this point you might be disagreeing with me because you only have to glance and feel dizzy, glance at Matt Turk's kind of annual diagram that he publishes and kind of feel dizzy and say, look, we've done a lot in the data. We've done had a lot of progress in the storage, into parallel processing, massively distributed files. Like we've done a lot. We've done a ton of tools around ML ops and ML flows and so on. But what hasn't changed is our high level kind of approach, our organization and architectural approach to managing data. So let me explain what I mean by that. So on one side of your organizations, you have the tech teams running the business. They build applications, they build the microservices. Each of these services has its own database. They're nicely organized around the biz DevOps. I mean, yes, of course, there are a lot of organizations not there yet, but at least that's aspirations they're moving toward. And they keep the data, we call them data on the inside, I call them operational data plane. But for some reason, we have on the other side of the organization, a functionally divided data team that is responsible for getting data from these applications through, whatever means, put them into some form of a monolithic data lake and data warehouse so that we can feed our machine learning models and reports and metrics and so on. And I work with lots of data engineers and data scientists, and I know from experience that they are isolated. The people working in the domains often not incentivized to provide them the right data. And what they end up creating is this kind of labyrinth of data pipelines that are so hard to manage. They're very fragile. Any change upstream can cause, cascading failures downstream, and essentially dealing with, a large pile of accidental complexity. And on the other hand, they're under pressure. So on one hand, these DevOps teams, they're kind of oblivious to the data that they need because there's no contracts between them. I mean, in the best case, they're probably dumping some business domain events into Kafka and say, here you go, you data scientist, data engineer, go pick it up and make sense of it, and then turn it to, on the other hand of the organizations, to all of these use cases that they need that data. So you're stuck in between the users and the providers of the data without really being embedded into the domains where the action happens. And on the other hand, we have some form of a centralized governance, which I have all the empathy in the world for them, that they try to somehow bring, this kind of get the right data to the right person at the right time, but not having that effective position because they're coming too late in the picture to try to secure the data, to try to certify the data. So they become actually an ineffective bottleneck. So these sort of challenges, I think the root cause of the challenges with rapidly responding to needs of the data, to be able to provide high quality data right then and there, when the data is generated, is the result of this decision. I mean, I have almost comically, kind of simplified the world of big data into this one big purple box. But fundamentally, organizationally and architecturally, we have a very monolithic kind of approach that we expect this system that we've created to gather data from all sorts of places, because data is absolutely ubiquitous. It can come from any parts of your business internally, or any part of business externally or outside of your business. And your innovation agenda, a lot of the data-driven or data-oriented strategies require that data generate function type of, experiments, but it's very, that becomes a bottleneck in the middle. So data mesh looks at these trends, and it says, okay, if the complexity is not slowing down, if the proliferation of data sources and proliferation of kind of data use cases is not slowing down, we need a model to kind of manage data, get value from data that doesn't approaches this plateau in terms of, time to market, in terms of getting value from data, in terms of immunity to change. So it tries to take this as its default position. So this inflection point is where we have to get started from. We have to work with the grain of organization complexity. We have to work in step with constant change and have a model that can scale out. So what is it? Is a decentralized socio-technical approach to managing, sharing, accessing, analytical data at scale. And the scale here is not necessarily, the volume, variety, velocity. These problems we have dealt with already. I mean, we've been in the deep end of technology trying to address the volume of the data, with kind of starting with Hadoop, with a variety, with the object storage and the different kinds of storage, and the velocity with kind of the streaming technology. We've addressed those. The scale is the scale of complexity of organizations, the scale of access to the data, the scale of use cases for the data, the scale of sources of the data. Why do I call it socio-technical? Well, hopefully the rest of this talk will answer that question, because we can't just talk about technology without talking about people. So it's an approach that affects the organizational structure, how we measure success, and as well as technology. And it's basically founded in this domain-oriented decentralization. So what is analytical data? I don't think I have to explain that to this group, but nevertheless, I have this diagram here. I mean, the data that data scientists and data analysts are used in their daily job to train their machine learning models, to generate metrics. The data, the feature stores that we call feature stores DOE, like the actual features that the machine learning models use. These are all analytical data. Often they are there so that we can make some sort of either predictive analysis or kind of, diagnostic analysis, look at the past trends, look at the future recommendations, right? And then optimize the experience of our customers, optimize the way we run the business. And analytical data, beyond being kind of big and diverse and have variety and velocity, it also has a few different characteristics that makes it actually quite different from operational data that we put in our application database set. First and foremost, it's a temporal kind of data. You need to have access to all of the changes that happened in the past. You need to go back to the data in the past and then be able to kind of see the trends that you want to predict for the future. So there's a temporal access to it. Many applications have no incentive whatsoever to keep the data, the log of all the changes happened, or the log of the data at a state of the data at different points in time. That's not what applications usually need. Applications usually need, in majority of cases, is what's the current state of the data? How many customers do we have? What's the name of this customer? What's the address of this customer? And so on. The other thing is that despite the fact that we are modeling heavily this data from the point of origin, from the point that it gets created into some sort of like canonical model in warehouses and so on. Despite that, data for analytical purposes should be business truthful, should be as close as possible to the facts and realities of the business before it gets modeled, to the point of kind of unrecognition. And it's ubiquitous. It can come from anywhere. And of course, it has a large scale. And I talked about the scale. Really, the scale that data mesh tries to address is the complexity in terms of the sources and in terms of use cases we have. We're no longer just looking for, a few reports or few statistical analysis here or there in, a couple of different features. The ambitions of organizations that, I work with is that, improve the experience of customers at every touch point using data, improve the features that applications are built using data. So the aspirations that have grown probably beyond what the technology can give us. So if you look at that, if you remember that inflection point that I said, okay, look, we need a model that can scale. We need to remove a bunch of blockers. And on the left-hand side of this slide, I have the blockers that need to be removed. Well, we need an approach that rethinks that centralization of technology and teams. We need a model that addresses this concern that by the time the data has gone through the data engineering team, through the pipelines, to the analysts, it got remodeled, it's lost its business truthfulness. So let's close that gap. This whole data pipelining architecture that we've come up with is fairly fragile. I mean, I can see the amount of technologies being thrown at kind of harnessing the complexity of data pipelines. And I think we should step back and say, do we need that? Is there a different approach that doesn't lend itself to this really complex and fragile solution? There's a lack of data ownership and accountability. I mean, the people that are actually best positioned to own the data, to be the custodians of the data, are the people that are generating it. There are the people that are, consuming it, not the people in the middle. And then we have, yes, organizational structures that creates this, data team in the middle. We have a lack of talent. I mean, you are data engineers, data scientists, and you know how hard it is to find people with your talent and with your experience. So that approach has to bridge the gap between the majority population of technologists today, generalist technologists, to be able to do what you do with less friction, with less specialization, with a new set of tools, thought, in a way that can enable them. And the governance, we need to have a model. We have to address this governance being a bottleneck and not being effective. So we need a governance model that can still achieve those noble objectives of governance in terms of privacy, security, assuring security, quality, and so on, but be able to be effective. So data mesh, no pressure. There's a lot of things to address. Data mesh fundamentally tries to address these blockers, create some enablers so that we can have that kind of hockey stick kind of curve. There are 4 principles. I love to always think and solve problems from first principles before jumping and throwing, an architecture diagram or a technology. And I want us to really think through, if you are solving this problem that we're in terms of complexity of organizations and meeting the ambitions, what would be some of the first principles you come up with? So these are the ones we observe kind of working. For the rest of this talk, I will introduce all of them. I will show the kind of their implication on organization structure, their implication on technology, architecture, and hopefully I will convince you by the end of this talk, if you are large, complex, hairy organizations with big aspirations around data, and this is part of your strategy, perhaps it's worth having a look at what data mesh can offer you. So the 4 pillars, they're complementary. The very first pillar is around decentralization of both architecturally of data as well as organizationally, moving the data sharing, the responsibility of data sharing to domain-oriented teams, similarly to what we had done with the biz dev ops. So we need biz dev data ops, I guess. And architecturally also allow to have autonomous pieces of the data, autonomous data sets that you can, while you can still run federated queries or join them and correlate them, they can independently evolve and they can have an independent life cycle and be changed independently. So that's number 1. So that's just the way we're going to get the economy of scale by being able to kind of scale out different teams working with different data and providing it and remove that bottleneck problem. But once you do that, the second principle is addressing the concerns that may arise from doing just that, which is data siloing, right? So why my e-commerce team is incentivized to share all of the user interaction events that are happening with the website, which is very helpful to the e-commerce team. They can personalize perhaps a recommendation, but they may not be incentivized to share that data for other purposes, right? For other usages. So the data as a product is a set of principles, a set of organization structure. There's an architectural structure unit, introduces an architecture unit. It's all about sharing high quality, trustworthy data with all of the information and computation that keeps that data alive and makes that data discoverable. So that's the second principle. And the third principle is really to reduce the cost of ownership. It's about creating a new set of kind of platform capabilities that allow this now cross-functional teams to not only run applications and build business function, but also share data, use data, build ML models that serve their applications. And finally, federated computational governance is about a new model of governance that operationally is built on federation, makes the concern of governance a responsibility for everyone, for all of the domains that are sharing and using data, So it's a federated operational model. And from the technology perspective, it assumes that almost all of the governance concerns, quality, encryption, retention, location of the data, all of that can be computationally coded and enabled by the platform and adopted by the data product and enforced by each data product. So, and none of this, to be honest, is novel. These are learnings that we had over the course of the last 2 decades. Try to bring decentralization to operational data applications and going to cloud. Let's bring that to the world of data and adopt it for data. The relationship between these, I will go through them, but the main pillar is really that domain-oriented decentralization and ownership. Data as a product prevents data siloing, self-serve data platform reduces the cost of ownership for cross-functional teams and empowers these autonomous domain teams in sharing data. And the governance is really about increasing the interoperability between the different data products, increasing the engagement of the different teams, and making sure that of course, the governance concerns are met. And then the self-serve platform automates the policies of the global governance that we want to impose. So what does it kind of look like? This is some sort of an architecture, I guess, diagram that I have for you. So you still have your biz dev, ops domains. You still have the folks that are responsible for a business function, like maybe it's routing, logistical routing, or it's product catalog or any of that. They're building applications, but those teams are now augmented with new responsibilities, new perhaps team members that are responsible for the data that's being shared from that domain. So this data, I use this notion of a style or design notion of a hexagon to show this concept of data product. So now my product catalog is adjacent to the catalog microservice. There is a catalog data product, which I will explain in detail what do I really mean by that. But it's basically, its job is sharing discoverable, understandable, trustworthy data about all of the catalogs that we've had, or states of the catalog we've had in the past, and we anticipate, kind of being refreshed, like kind of on some sort of a cadence. So it's an analytical view of the catalog, and you might have multiple data products. So then you will have new roles like the data product owner. The same way we have application product owner, we will have a data product owner, we'll have data product developers. And to enable that, we'll talk about a multi-plane kind of data platform that not only gives you those utilities you have today, like your Spark clusters or your Beams or your ML flow or different storage, excuse me. Not only gives you that, but also gives you a new set of experiences so that as a data product developer, you don't have to worry about provisioning of different bits and pieces. You can just say, oh, here's my declaration of my data products, go and create all of the, kind of the utility level ingredients of the infrastructure that I need, or this is my data product, deploy it, or this is, there's just really abstracts a lot of complexity and talks and provides you capabilities at the level, at the unit of a data product. And then you have the mesh experience plane that provides you as a mesh of a data product. So run this federated query over all of these data products, or search for customer information. Which data products can I find customer information? You'll show me the lineage. So all of these capabilities that go across multiple data products, we call this the mesh experience plane. And finally, the policies that need to be globally and consistently applied to all of the data products, then provided through this policy as code, essentially, that gets embedded into every data product. So these are the ingredients of data mesh that needs to come together. But let's deep dive a little bit into each of these pillars. What is domain ownership? What does domain ownership mean? So around 2000, early 2000s, I don't know if folks are familiar with this book, but in 2003, Eric Evans published this highly popular, and it's still, I think it's going to be an evergreen book. If you actually, it's a very large book if you get to read it, called Domain-Driven Design. But if you look at the subtitle of this book, it says Tackling Complexity in the Heart of Software. So what was happening in early 2000s? In early 2000s, we had moved our businesses to web. We had, all sorts of e-commerce. It started with playing with e-commerce, with the, classified newspapers on internet. Like businesses were moving to internet. The application designs were getting more complex, more aspects of the business becoming digital. No longer a design that required modeling of an application at an organizational level worked. If I use the same analogy in the world of data, no longer a canonical model in a warehouse can work, because it becomes, it slows you down, that approach. No longer silos of different applications written work. So having silos of different application databases, that doesn't work for us either. And we couldn't live with no intentional modeling. So we needed some form of a modeling, but we needed a modeling that was in step with organization complexity and could grow. If you have multiple teams, they need to communicate. How would you model your application? So Eric Evans came up with this idea of domain-driven design. He introduces a bunch of patterns, call them strategic design patterns. And some of these are greatly applicable to us now as we go through kind of the complexity of the big data space and data analytics ML space. So he introduced the concept of bounded context. A domain is a part of your business that has an autonomy for a set of activities to produce a particular outcome, has a ubiquitous language to describe those activities. So if you're in a logistic domain, you use a different language to describe the product. Product is probably your parcels and packages and containers, and right? If you're in the sales, when you talk about the products, you're talking about kind of the aspects of that for selling. What is the picture we want to show on the website? If you talk about the product in the domain of design, where you're designing it, you're saying, okay, what are the material we need to source, how many buttons, what color, and what style, and so on. So you have a different bounded context in terms of the language, in terms of activities you need to do. However, this concept of a product is an interconnected concept, right? It's a policy. And it has a manifestation in design phase, it has a manifestation in logistics space, and a manifestation in sales phase. So you need this context map and ability to map these concepts from one domain to another. And then, you will have a ubiquitous language to describe that model. So these were a set of patterns to allow us to decouple hairy, monolithic, slow to change models into independently evolvable models that at the time he was applying it to the software, and we can clearly apply that to data itself. So what would that look like? This monolithic kind of warehouse or lake will actually turn into kind of, again, I call this data products, domain-oriented, autonomous and autonomously changing data products that are interconnected. So if you have, for example, a set of data products that are probably aligned with the point of origin where they get created. So if you have an order management, like e-commerce orders, you have an e-commerce application, you're getting e-commerce orders, so you will have e-commerce orders data product. Some of them might be aggregates, so you might get your retail store orders and the e-commerce orders and aggregate them together as all of the orders that we see, because it's a very useful aggregate to have. And then you have data products that are aligned with the domains that are closer to consumption. So if you have an ML model that's running and making recommendations for your customers and does that in whatever cadence, whether real time or in batch, then those recommendations themselves become a data product, but their content, the content of that data is not so much aligned with the source where the data came from, is aligned with where that recommendation wants to get used. So their design of the recommendation is based on how we want to use that, right? The recommendation. So that's kind of how you can start classifying different types of domains that you have and have those teams own this new concept of the data product. So in retail, we will have now a biz dev data ops team in production, the biz dev data ops team in distribution, in selling, and each of those you will have applications and also data products. Data products in production might be designs, items, sourcing, distribution might be warehouses, shipments, parcels, selling might be catalog product stores, and the data is constantly changing. So the transformation that needs to happen when we move to this domain-oriented data sharing, we stop thinking about data need to be flowing from source databases into pipelines into wherever, into lake or warehouse before it can be used, and really thinking about the data at the source can be shared and can be used right then and there. We stop thinking about one canonical model to rule them all, and we agree that there might be different models and different domains might model the data differently, but we need to have interconnectivity between these models. And there are approaches to that, like in the world of kind of operational data, like approaches like the GraphQL Federation tries to do that. In the world of, I guess, web, the linked data initiative was about linking data. So we can bring those ideas to the world of the analytical data and create that multiple model, linked model scenario. This idea that there is only one source of truth, I think that's just the holy grail that we will be searching for the rest of our lives. There is no one source of truth. There are many sources of the truth. We want to make sure that all of these sources are reliable. All of these sources have quality built in. And we stop really decomposing our architecture around technology. Here's the application database, here's the pipeline, here's the destination sync. We want to start creating this domain-oriented technology and teams. So at this point, you might say that, well, that's going to create a bunch of siloing. I mean, we talked about that. Why would production team or logistics team share their data? And that's where this very, very important pillar of data as a product come to play. Data as a product is really the convergence of data and data sharing and product thinking, right? So, and I think there is a ton of kind of aspirations and learnings from the world of product management and product thinking that we can bring to the data sharing. Sorry, my slides jump around a bit. So what is a product? There are many definitions of a product, but what I want to focus on is what I have taken from Marty Kagan and from his book Inspired. A successful product is the thing that is usable. First of all, you can use it. I'm using a clicker. It can be used. It's valuable. It delivers some value, and it's feasible. So let's bring these characteristics to data. What does a usable, valuable, feasible data looks like? So again, I use this concept of hexagons to show data products. Well, in case of data products for data mesh, is a data that first and foremost is delighting, is usable, and it's delighting the data users. And data users are data analysts, scientists, and you folks on this call. And if you think about, and we've already talked about the data needs to be domain oriented. So sorry, just for some reason in this slide I've jumped from retail to pharmacy or to insurance. So actually let's talk about our last example, right? So you have orders. Let's say you are the order management team domain and you're providing orders, like all of the orders have been put, canceled, returned, refunded, in your organization for all of the customers you've had. That's the data product. But when you think about the access to that data product, data scientists, their native tools that they use today would require, access to some sort of a lake-like storage with Parquet files and be able to, read data frames basically from it. Data analysts don't necessarily like that access. What they like is be able to have some sort of a multidimensional kind of relational database so that they can run very diverse queries, SQL-like queries on the data. If there is a data intensive application, they probably care about events. Just show me the order, as events that are happening. So then your data product, first and foremost, is domain oriented. And secondly, most importantly, it provides endpoints, APIs, access points to the same data for different modes of access to satisfy the very diverse range of what we call analytical access to data, right? From files to graphs, to events, to multiple modes of access. And then on the left-hand side, I put a bunch of different capabilities that need to be baked into this thing we call data product so that it can be discovered. You know, it needs to have some sort of a global address. It needs to have discoverability information that we can find it and search for it. It needs to be understandable. Not only it must have the schema of the data, but it has to describe its semantic. It has to have, you know, computational notebooks that show how this data can be used, what's the statistical nature of the data, like all of these kind of wonderful computational documentation that can help us understand data. It needs to be addressable so we can actually connect to an endpoint and start, you know, consuming and subscribing the data. To be secure, most importantly, interoperable. If there is a concept of a product that goes across multiple boundaries, goes across multiple data products, that product, that shirt or that watch or whatever the product is, need to have some sort of a unique ID so that we can join and correlate the same thing across different data products. We need to be trustworthy, right? And natively accessible. It needs to be valuable on its own. To me, these are non-negotiable intrinsic characteristics that somehow, with the use of technology, we need to build into a data product. So then you might say, okay, what does this beast look like? Like, what is this hexagon? What's inside it? And to describe it, I take this concept from evolutionary architecture, this concept of architectural quantum, and I know it's like a big word and a little bit alienating, but the beauty of this concept is that it's the smallest unit of your architecture, right? It's the little data product that has all of the structural elements so that it can independently be deployed, independently deliver value, independently do its job. And in case of the data product, doing its job was providing that long list of characteristics, be discoverable, provide the data in multiple modes of access, be understandable. So then what are these structural components that are in this hexagon? Well, there's code for sure, because every data product has some transformation logic. There's no pipeline anywhere in data mesh, unless there's a pipeline inside the data product. So maybe there is a transformation pipeline inside the data product that is, you know, receiving data from, let's say it's the orders data product, it's receiving data from e-commerce orders and retail orders, and it's merging them together and creating one aggregate view of the orders with unique order IDs and so on. It has code for APIs that serve the data. It has code for policies that needs to computationally and automatically enforce. So it has code for encryption of the data on write or read. It has code for access to, you know, automatically verified access control when people come and use the data. It has the data itself, so multimodal, perhaps a storage of the data if our technology doesn't support multimodal access of the same underlying storage. It's the data, I mean, without the data, we won't be having this conversation. And that needs to have a way of describing what's the infrastructure that it needs to run on looks like. What are my infrastructure dependencies? Does my code need to run on GPUs? Does my code, you know, does my data require SQL storage, or does it require graph storage? Does it require file storage? So it has to describe its dependencies so that the infrastructure provisioning underneath can provision all of the resources that it needs. So let's look at it with an example. I keep jumping around. I just realized my examples jump around from different domains. So let's ignore the labels. I'm going to go ahead with the retail example. So let's say this data product is providing styles, right? So sometimes if you're in a data scientist, you're familiar with generative kind of machine learning models that give you, they create new ideas. And this generative data product is providing styles. Like it tells you, you know, to run your, I don't know, black skivvy shirt with black pants and these shoes and that other. So to do that, it needs to get data from two upstream sources. Let's say it's getting data from the orders that have been put in place, and it's getting data from a catalog service, right? That it's getting, looking at what the catalog of the product, what are the shirts and pants that we're selling today, what are the orders that people have put in place, and then it receives that through the input ports, I call them in data mesh. So it's subscribed to that data and continuously receive that data, and as the data comes through, it makes kind of recommendations around the styles, and then it serves the styles as a set of kind of in a multimodal access and as a set of time-stamped information. So styles today, styles tomorrow, styles today after. It has downstream, probably a recommendation, maybe engine is receiving that styles and incorporating the idea of the styles into recommending what products people need to buy, why they buy the black shirt. But it also has a set of APIs for discoverability and observability. So it has a set of APIs that provides identity, semantic, metrics, documentation, all of this good information that allows us to discover this thing, learn about it, and also observe it. It provides a set of metrics so that we know it's performing with the cadence that it needs to. And it has a set of APIs for its controlling its policies, right? So a lot of organizations are uncomfortable with a particular domain to decide independently how they want to encrypt data or what's PII. So they may want to have a centralized way of controlling how the policies need to be enforced, so the configuration of the policies can be done. Or you have a set of administrative functions like GDPR, the right to be forgotten. So maybe you have the evoke or kind of erase or some sort of administrative kind of highly privileged function, that API that you need to expose. This is showing all of the kind of capabilities at a very, very macro level that its Hexagon needs to have an independently deployable, evolvable data and processing. So we're bringing compute and processing, not at a physical level, but at this logical level together to always provide trustworthy, lively data right then and there, close to the source or close to the consumer. So the transformation that needs to happen with the concept of the data as a product is this. Sorry, I'm just checking the time. So I still have another half an hour, right? We're here today. Yes, I think we do.
Yeah, no worries. We still have a little bit over half an hour.
Okay, great. So instead of thinking about, we always hear this thing, data is an asset, data is an asset. I challenge that. To be honest, I don't want to share my assets with anyone. I want to put them in a bank and lock them up and keep them for myself. So I think data as an asset is not necessarily the best analogy to use today. I think data is a product, because then we invert the model of thinking and our biases to hoarding data to sharing data, because product is all about delighting and pleasing and making the life of their users easier. So data as a product, I think, is a better analogy to use. That affects also how we measure success, right? If data is an asset, how would you measure your success? Well, I count them up, and the larger the number, the more successful I am. The more tables and terabytes I have, the more successful I have. Does it mean that you're really getting value from that terabyte? Not necessarily. But if I count how often this is being used, the happiness of my data users, how happy are they about the quality of the data I'm providing? How quickly can they get to the data and use it? How usable it is? That has a direct relationship to actually getting value from the data. So that's the first one. And I think this idea that data is just a byproduct of running the function, running the business, and then kind of dump it somewhere for somebody else downstream to use it and cleanse it and model it and turn it into a product, that also needs to we kind of need to put that in the past. I think data is a product right then and there when it gets generated, and it has to be by the same teams need to be served as a product. And as you saw in my previous slide, it's not that data, you have your pipeline separate and then your data separate. Actually, you need to kind of bring the portion of the pipeline that is related to a particular data transformation and put them kind of together and manage their life cycle together. So at this point, you might say, wow, that was a ton of extra work that this biz dev data ops need to do? How is that even financially viable? Do we need to go and hire another 100 data engineers and spread them around into teams? I mean, that's one reason we have centralized data and analytics, because we don't have enough of those skilled folks. So, and to that, I would say, well, we need to rethink technology. I mean, it's not the first time we've gone through a wave of change. We went through mobile, we went through cloud, and we managed perfectly to upskill, cross-skill our people, our generalist population. So what is it that we need to do to enable this autonomous cross-functional team? And that's really the role of the platform. I mean, there's a lot, of course, education, upskilling, and so on, but the platform has a big role in there. So let's talk about this. I want to start with a comparison. You might say, in the previous slide when we started, I showed that Matt Turk kind of slide of all of these technologies we have: Snowflake, dbt, Spark, Beam, all of these things. Why do we need more technology? Well, let me give you a little comparison. On the left-hand side, and I'm sorry, this is a bit small, this slide. On the left-hand side, I will show you the approach to the platform, the data mesh platform, technology that enables the users to do their work. And on the right-hand side, I show you the approach to the platform today. So the platform that we built for data mesh is about serving autonomous domain-oriented teams, right? Serving people, some of them are developing apps, some of them are developing data products. They're working closely as part of the same domain. And there are many of them. They're not just one team, right? There are many, many different teams need to work autonomously. Platforms today are majority designed to serve a centralized data team. Yes, you might have multiple data teams, but at the end of the day, actually, you run into very hard limits, as we have run into it when you try to have, a different allocation of resources completely to different accounts, different teams. So it's a different style of usage, centralized versus domain-oriented. On the left-hand side, again, the platform for data mesh is about managing autonomous, interoperable data products. And we talked about what data product is. It's data, code, policy, all together as one autonomous unit. On the right-hand side, the existing platforms we have, they manage pipelines. So you've got a bunch of ones to orchestration of pipelines. You've got a bunch of them for policy with the governance tools. You've got a bunch of separate tools for managing storage. They're very kind of fragmented around the boundaries of the technical functionality, as opposed to a domain-oriented data product which brings multiple functions together. On the left-hand side, you need a platform that plays nicely, whether you're running an application or next to it, you're building a data product. Right now, we have a very dual stack. If you're on the application side, you're working with Kubernetes, you're working with kind of all of the frameworks that run microservices, you're defining your data interfaces with GraphQL. Come to the data set side, you're running a Spark cluster, not on Kubernetes. In the majority of cases, I've seen one company that does that, and it's very hard, and they've done it because they had an internal private cloud. You have your data described in a very different model, not the same model. And I'm not saying they have to become exactly the same. They might remain different because they have different kind of needs. Workload of processing, a workload, analytics workload is very different from processing an operational workload, but they need to be interconnected a little bit more nicely, right? So it's not so difficult to connect one end to the other, and I need a giant pipeline in the between. Again, the platforms for data mesh will be designed for generalist majority, would try to abstract a lot of complexity that requires a specialty down underneath the platform APIs. The platforms today, they think they're dealing with majority specialists, right? Data engineers, data scientists. Data mesh platform favors decentralized technologies, and existing platforms favor centralized technologies. Bring your platform to my warehouse, and then I'll give you a bunch of connectors to dump your data here and bring your processing here. But that doesn't really lend itself to this decentralized model of we can connect to the data wherever it is, right? It just has to be on my platform. And finally, the platform in data mesh is very domain agnostic. It's a set of general tools that every domain can use and get enabled, but doesn't have the domain knowledge in it today, the data platforms both encode kind of the data, the domain-specific concerns like data, the designing, the modeling the data, as well as the domain agnostic. So why we need this platform? Let's bring it together. We need the platform for first and foremost so we can have a unit of value that we exchange. So you've got your data producers, your e-commerce application dev, you've got your data consumers, the people that are building the style machine learning model, and the unit of value you want to exchange is data products. So we need to be able to enable that exchange of value. And we need to do that in a way that these teams are working autonomously. We don't have this tight coupling between them, right? We can do our jobs independently. We need to be able to share that value without friction, without running around the organization figuring who owns the data, without pulling our hairs out, trying to understand what the heck these field names that are cryptically encoded actually meant. So we need to be able to provide and use data without friction. We need to lower the cognitive load. So cognitive science definition of cognitive load is the amount of working memory you need to be able to understand a new information put in front of you. So that depends on how the information is presented to you, how much information you need to be able to understand that. So if we lower that by providing simple APIs to abstract a lot of complexity, then we can really lower the cognitive load of the teams. And we need to be able to scale out, as in, I have 5 different products, but I can yet connect them. I can still join them. I can write some data processing code that, reads data frames from 3 different places and still be able to correlate them. So it has to enable some sort of interoperability. It has to have it must standardize how we serve data. It must standardize how we describe the policies, how we model the data. And if you did all of this, hopefully what would happen, the outcome of that at the end of the day is what we started. We want to be able to innovate at scale using data. And that only happens when that innovation is embedded into every single team, not externalized to it, thrown over the wall to the data team. The notation that I use architectural notation that I use in my talks around the platform is this, very simple, a line and a bunch of lollipops sticking out of it. So why do I do that? Because I want to bring your attention to the APIs. Those lollipops are, I guess I've taken them with me from 20 years ago learning about UML. There are interfaces to the platform. So I don't want us to, for this talk, worry about, okay, what's the exact underlying technology? I want us for a moment to look at the surface that we enable other people to stand upon from the perspective of the APIs that these folks need, the interfaces that they need. So this is a lot happening on this diagram, but I'll just tell you the narrative behind it. If in the middle you have that mesh of a data product, right? You have your catalog and you have your products and you have your e-commerce orders, and these are all interconnected because either they're consuming from data and from each other and providing data to the other, or the data models are interconnected, right? The definition of the product refers to parts of the definition to another data product. So you have this interconnected, lively mesh of continuously evolving and changing data products. At the data product experience plane, at that level, this concept of a plane is just a classification of a set of services and a set of APIs. You need to give a very high level API, and I will go through a detail of some of these too, so that the person who's dealing with the data product, they just think at that level. They don't think below what's below it. They just say, create a data product for me, data quantum, deploy it, set the privacy level, create documentation, connect to it, read from it. So it's very, very high level at the level of a data product. Below that, the utility plane, of course, it will provision different types of storage, provision a query engine, provision a flow orchestration if you need that for your transformation. And on the top, from the mesh experience plane, you get a set of APIs that operates on the mesh. Search the mesh for a particular entity. The knowledge graph, show me the interconnectivity of this knowledge graph that is emerging from this interconnected data product. Or monitor and show me the lineage of the data going from one to the other. Or what are the global policies that we want to configure so that all of these data products adopt. And of course, these these APIs that are interdependent, right? The mesh experience plane uses data product experience plane, and the data product experience plane uses the utility plane. So let's take one of these examples. Let's look at the journey of a data product developer and say, okay, if this person wants to generate these, orders or catalogs, data products, what are the phases that we'll go through? Well, they will go probably some form of inception to say, okay, who wants to use catalog data products? Like talk to a bunch of people, talk to a bunch of data science or other domains and say what they need. How long do we need to retain the catalog changes? What information do we need to put into it? What sort of modes of access we need to provide? Bootstrap and build, get started, bootstrap it, source the data from the sources. Data are always coming from somewhere else, right? Test and deploy and monitor and then maintain and evolve. So then if you look at how this depends on this journey is enabled by the data product, well, your data mesh experience plane at the time of inception will give you some search ability. So show me all of the data products that have some information about catalog. Show me all of the data products that have some information about the orders. So I know where I can source my data from. I need to be able to connect to that data product and either run some queries in a pool-based model or be able to subscribe to it and look at all the changes that are happening, like what's the cadence of this data product getting refreshed? How often do I get new information? What's the bulk of that? What's the volume of that? So start kind of looking at the data itself. And then once you're ready, you have to build your Hello World data product. So the Hello World data product is initialized at a data product experience plane. You probably have an initialize command that gives you a scaffolding of, okay, what's the standardized data product looks like? What files do you need to have? What do we standardize in terms of technology? Are you going to write a bunch of Spark jobs or not? And then be able to build, deploy, and so on. So that's kind of how you can, if you're building a data mesh, and if you think about the infrastructure, this is the approach I would suggest you take from the experience of the users to the capabilities. So in terms of now, let's say you got to the point that you've got your Hello World and you want to deploy it. So you've got some code, you've probably got your, the code that's actually transforming data. You have your policies and your spec to manifest to say, okay, what resources do I need? Do I need a bucket storage? What do I need? And you just basically say deploy to the platform, and platform will go and provision one of those running live hexagons, right? Your transformation will be running, your storage will be allocated, and here you go. And of course, that still requires to use the technology we have today. So it still requires to provision a bunch of things that sit underneath it, the stuff that we work with today. So the change that needs to happen going from, the platforms that we have today, don't think about it as one big platform, really think about it as this collection of protocols and APIs. And there might be 20 different vendors sitting underneath that, but think about it as these APIs. We're moving from serving just a specialist, monolithic specialist team to a generalist population. Of course, there will always be a specialist, but we need to cross-skill. Remember the skill gap that we have right now. We have to cross-skill specialists, generalists. And don't think about it, I need to buy a catalog. Think about it as experiences. No, I need to be able to search. I need to be able to discover. And then work backward and see, okay, what tool do I need to buy or build? What mechanism do I need to buy or build? This would be my, recommendation around thinking about the platform. And the last pillar, okay, how does governance look like in this crazy mesh of, data, different data products running by different teams, and how do we organize ourselves? So there are two components, in fact, three components to the governance, but it was going to be a very long phrase if I put all the three components. There's automation, automation, automation. How can we automate all the concerns that the governance need to guarantee as a discipline? How do we operate the governance so it's a bit more federated, it's not centralized? And how do we embed all of these policies into every single data product? How do we make sure the consistency of the policies applied to every data product? And the beauty, the challenge really is that the governance now needs to manage this equilibrium between centralization. There are some standards that we want everyone to adopt. We don't want to have 50 different ways of describing a model of a data product. We want to use the same modeling language. but, and decentralized, the equilibrium between decentralized, but we want to allow every team to model their own data because they know what the data looks like. We don't want to centralize modeling, but we want a centralized approach to modeling. So this equilibrium, to manage this equilibrium between centralization and decentralization, you need to have agree that accept the fact that these teams are independent and they're autonomous, give them the autonomy. We need to assure there is an interoperability despite the autonomy. We need to agree and accept that this is going to be a very dynamic topology. Data products will change, the versions of them to change. So what can we build into our policy so accepts that rather than have this synchronized stamping, gold standard stamping data products? That's not going to work given the amount of change we will see. And let's take advantage of automation. Let's take advantage of this platform that we have underneath us. So from the operating model, these are the elements of it. So you basically think about, because this is a decentralized model, I need to have an incentive model that all of these people to kind of come together. So there is a group of people, a federated people, set of people that decide based on a set of principles, what do they need to standardize across policies, across all of the domains? What do we want to leave to the domains to make decisions? What decisions we want to globalize and what decisions we want to leave locally to the teams? So the ones that we want to globalize, let's define those over time. Let's get the platform to automate that. And let's get the data product as part of its blueprint, have access to that automation and be able to embed that. So let's look at an example. Let's say the teams come together from domain representatives, from, of course, someone needs to herd the cat, so there's administrative function. There's subject matter experts, the people that understand security, perhaps legal, they understand the legal ramification of like storing data, retaining the data, and you have platform representatives. So that's your team. And let's assume that the policy that you want to enforce in a standardized fashion is how do we define quality? What are the quality metrics? And let's say you do your research and you say, okay, actually the W3C data quality vocabulary has a nice set of metrics that each data product can propose. Like they can say, what's the percentage of, what's the degree of integrity? What's the timeliness? What's the degree of completeness? They can articulate in a quantifiable way a set of metrics that constitutes quality. So when somebody comes to read the data, they say, oh, this data is not complete because it's missing a large portion of the population and it's not okay for my use case. But maybe somebody else says, oh, no, that's actually okay. I have the tolerance of that level of incompleteness, but I can use the data. So that set of guarantees will help the understandability and trust in the data, right? And then the platform says, okay, that's awesome. We will provide a library that the data products can embed in its code that exposes the APIs for surfacing these metrics. We would also provide the library for them to calculate as the data arrives. They can provide some parameters and calculate the different metrics. So then that metric generation and metric sharing becomes embedded into the data product, automated by the platform. So the change really that needs to happen here is moving away from a centralized team of data experts. Usually data governance are actually the stewards of the data. They understand the data, to a set of domain experts. They're not responsible for data quality anymore. They're responsible for defining what constitutes the quality, and the domain folks are responsible. Those domain product owners, data product owners are responsible for quality. They're not responsible for security. They're responsible for defining what constitutes security. Platform implements it, and the data product owners are accountable for making sure, responsible for making sure that security happens. Of course, there will be a monitoring in place, automated monitoring to make sure that the data is compliant and using. And then the measure of success of a governance of a mesh is not based on how much data the mesh has, it's how much interconnectivity between the nodes mesh has. How many data products are using each other's data, how much value we're generating through these network effects of the mesh. So I have a few more slides, maybe I can quickly, you might say, okay, this was a lot of information. How do I get started? What does this look like in practice? And I would say, I love to leave you with this quote from Immanuel Kant that we have to, if you want to get started, if you're someone who's in a position of influencing or directing or managing change to building a data product, you've got to look at the big picture. Like, where does this mesh fits into the bigger picture? And the bigger picture usually looks like this. Like, you've got your applications on the top, the points of actions and interactions with your customers. They generate data, domain-oriented data that gets used by ML analytics, which then augments those domains. So in this, and then underneath, you've got your data and ML platforms, right, to enable that. So it is a transformation at an organizational level. And like any transformation, I would say, it has to be driven by the business. It has to be somewhat evolutionary. Day one, you're not going to have the full scale change. So you get in an evolutionary manner, you need to kind of evolve it and do that in an iterative way while delivering value end to end. So often when we do these exercises, we look at that kind of cycle of intelligence from data to actions to data to intelligence and back to intelligently augmented actions. And we say, okay, let's work backward. Let's find a use case. Let's be business driven. The use case might be we want to automate the style generation, so we can make recommendations to style, so we can increase the satisfaction of our customers and deliver value to them, and of course sell more products while we're at it. So then we will say, okay, we need a slide generator ML model. We work backward and say, okay, for that we need these data products from catalog data product, orders data product, and what sort of platform capabilities we need to enable that frictionless consumption of the data and serving of the data. If you think about this as an evolutionary, and that's the kind of iteration, so you iterate over this, but you need to have some sort of a game plan as how do I evolve and scale my operation. So initially, when you're bootstrapping this full transformation, you might say, look, I'm just going to take a few use cases to drive this that are a bit low complexity. I'm going to start maybe a little bit more centralized with my platform team and domain teams. And then once you scale out, you will have, a very decentralized model. Your platform might be at the beginning very opinionated, only provide a few capabilities in a very opinionated way, not have 5 different technologies to serve the same function, but as you scale out, you might start, having a lot of different modes of, technologies for the same function. And population of users grow, right? You start with a smaller number of data users, and then you grow to a larger number of data users. But you need to have a plan to see how you would do that in an evolutionary fashion. So if you need more information, there's ThoughtWorks website. I've done a few talks on data mesh that is available. I gave you the URL to the book that hopefully you will, oh my goodness, these slides are just jumping around. And well, the journey of 1,000 miles began the first step, and you took the first step, came to this very long masterclass talk, and I wish you all the luck. So
thank you. Thank you so much. And again, with the links, because we had this for some of the viewers, maybe we can you can give them to us, and we can post them in the chat so they can access it directly. That would really help us. And God, we had a keynote earlier from a company that generates a ton of data, and if they saw this keynote, I think they would pop something, because it was basically doing the things that they were doing like the old way, and they had a huge database with a ton of data there, and they were chunking it, and then they were chunking it some more to bring it into the people that were actually using it. And seeing data as a product and not as a residual thing from collecting everything from the customers is just turning things a bit on their head, I think.
Yes,
Yeah.
My official title is the head of tech or whatever, head of the managing thing. My unofficial title is troublemaker. So
it is. It truly is, because we were trying to wrap our heads around it, and it requires a lot of change in the company. And we had a question as well. Let me see if I can find it. They were saying, is this actually feasible for huge companies, from big companies that actually use a lot of data? Because they have to change fundamentally, I think, at some point. I mean, you've said small incremental changes throughout the company, but implementing something like this is a huge task, I think.
Yeah, I mean, honestly, if you're not a large company with a
Mm-hmm.
complex and complexities of a large company, I wouldn't even say bother with this
Mm-hmm.
because the implementation has its own
Mm-hmm.
complexity, but
Yeah.
it's an essential complexity for kind of for the level of kind of the scale of organization you have. So early adopters of data mesh that
Mm-hmm.
I have worked with and I know of, they're all large companies. And if you
Okay.
actually go to another link, I should have put this, there's a
Mm-hmm.
Slack group and a meetup called Data Mesh Learning
Mm-hmm.
Community. And you will see a lot of presentations of companies that are adopting data mesh. And many of them, like, JP Morgan Chase is a large bank. I work with a large healthcare here in the US, with a couple of them, large multi-billion-dollar
Mm-hmm.
kind of organization. And you must have that level of scale to be able to get
Sustain this
value from.
change. Yeah.
Yeah, right. So but it's not that they start with an organizational wide change.
Mm-hmm.
Usually, let's say, in fact, I'm working with a bank in Europe, and for example, they start with say, okay, we want to look at in the credit and risk, or
Okay.
there's a pharmaceutical that I've worked with, massive pharmaceutical. They may
Mm-hmm.
want to start with, drug production, manufacturing. So
Mm-hmm.
even in a large organization, the beauty of it is that every domain is a large organization itself. So you
Yeah.
can kind of start from one domain and then extend it and learn and refine what works for your organization. And yes, it is a change management.
It is. And I was thinking about what you've said earlier, that if you're a smaller company, don't bother with it. But I was talking to a company again earlier today, and they've said the same thing. We've got a huge database, and again, chunking the data and making smaller bits of data from the raw data is taking up a lot of space, and the prices of storing the data are increasing. So do you think that data meshing can actually lower the raw amount of data that they use, or stop the chunking?
Yeah, I think I guess maybe that wasn't appropriate to say. I would say if you are feeling the pain of the solution I have
Mm-hmm.
operationally doesn't scale anymore,
Mm-hmm.
or how I want to use the data, there's a long lead time or wait time for me to be able to use the data the way I want to use it. If you have those points of friction and those pains, then I would say it's worth looking at data mesh, because that's you've reached the scale that your
Yeah.
organization can offer, the method that you've used can offer you.
Wow. So thank you so much. I know it's a lot to unpack, and people are still watching the keynote because we're running a little bit of a delay. So with further questions, we're just going to redirect them to you and maybe to the ThoughtWorks stand as well. Get the people there in the expo area, pop any questions that they might have. Thank you so much for being with us.
First, thank you for hosting me. Take
Again,
care,
sorry for waking you up so early in the morning.
oh,
But
no,
we
I'm
really wanted to
woken
have
up
you
now.
on. I
Take
can see
care.
the
Great
dawn
to be
there.
here.
Thank you. Take care.
Bye-bye.
Bye-bye.